So at the moment, I have a mass ratio of 2. So the green one has twice the mass of the blue one. And a coefficient of restitution, whatever the heck that means, of 0.5. Anyone care to guess what the coefficient of restitution might mean? Well, let's just try it and see what happens. So here comes the blue one, kablooey. That was exciting. All right, so so now let me add in this magic point, the center of mass, that we will figure out how to calculate. And allegedly, if we watch that, the red dot, which is marking the position of the center of mass, moves at constant velocity. Let me change the coefficient of restitution, and then we'll see what you think. It's now 1. Anybody have a guess for what the coefficient of restitution? Yeah. Good. It does. It has something to do with the collision. Yeah. Oh, somebody used the what? How elastic? What were you going to say? Give me, okay, but it's a number, so I want to know for realsies. I need a definition.
How much of the force is rebounds?
Okay, we don't need to use force. Christian.
I think that just when you get the speed of separation of the two bodies, you divide it by the speed of approach of the two bodies, then you get
So let's go back to equal mass. This is equal mass and a coefficient of restitution of 1. So what happens is, what happens to the relative speed of the two balls? Does it stay constant? Is it the same before and after the collision? What happens is the blue one is moving in, collides with the green one, blue comes to rest, the green one was at rest, the green one now moves off at the same speed. If I now take the coefficient of restitution down to something frightfully small, then you can see that they don't separate as fast. If I take it to 0, what should happen? Wait, what? Ah, it's love at first bite. Yeah, so that sometimes we call a completely inelastic collision. But notice all throughout, the red dot that marks the position of the center of mass just keeps moving placidly, straight line at constant velocity. All right, so the coefficient of restitution, as Christian mentioned, it's the ratio of the separation speed to the incident speed. Okay, how fast one is going compared to the other. Yes, sir?
What would you have to change in order to get the first ball to bounce off and transfer the other ball?
And you want the first ball to go backward?
Yeah.
Okay. Any suggestions? Thinking about ping pong balls and pickup trucks, for instance. We would want to make perhaps the green one more massive. Let's try that. So right now the mass ratio is 1. So let me yank that up. Okay, but I have nothing for the coefficient of restitution. Does it make sense that if the coefficient of restitution is 0, I can't get it to bounce back? Because the initial momentum is to the right. And if they stick together, then it has to be moving to the right. So let me give it some bounce. And that worked. Okay? Questions? Sir? Yeah, so when you have a collision, before the collision, one body is approaching the other. Okay, so there's some speed of approach. After the collision, they may separate. And so there's a speed at which they move apart. The ratio of the apart speed to the approach speed is called the coefficient of restitution. Okay?